Darren's under recording like that. Perfect. Okay. All right. So, my friends, good to see you back. We're going to do something today. I want to start off. I'm going to share my screen with you. Let me just adjust it. All right. Where did Zoom go? There's Zoom. All right. Sharing the screen. So, our folder for on Schoology looks like this. I did delete out all the stuff from first semester. We didn't necessarily need it. And so I do have how to get the book. So our books are in. So if you wanted to get a book for this class, so you had the worksheets, go and follow that link, and then you can go to the bookstore and pick it up when you are back on campus. If you don't, I will post the pages on here, and you can either print them off or you can just write them on a separate sheet of paper and show me that as homework. And then in our remote folder is obviously everything that you would need to know. This link I was able to set up on Zoom. It allowed me to go all the way through the end of February. So at the end of February, I'll have to change the link, which is not a big deal. It'll be, I'll modify it in here so we can see that. So that's what we got. And let's see. And then let's see. That's just whatever. But in the week 1 folder, and I'll continue down that, you will, for the most part, hope to just have weekly folders. And in each weekly folder, notice I have January 7th or January 8th, so today or tomorrow. Obviously, I just have you all today. Is a blank version of the notes. Once I get done with the notes today, I will put the filled out version right below that. And then the homework for today that'll be due on Monday is on this one. So you just have to click on it. It's your choice if you want to print that off, or if you want to, or if you wanted to write it down on a separate sheet of paper. It's your choice. So as soon as that comes up, it's trying to load. Computer's doing a few things at once. So you go through and it's going to be all the problems. And my hopes are that at the very bottom, this link, this YouTube link, will take you to all of the odd problems worked out. And you can do that. So tonight's homework will be all of the problems here. I wouldn't suggest starting it right yet because I haven't taught the lesson yet. But I will, in this folder for January 7th, 8th, and 9th, or 6th, 7th, and 8th, I will also, I'm going to have this video embedded on there. So when you go back onto the screen later today, you're going to see a video clip, and you click play and it's going to play for you. Videos are not worth points this year. Try a different.
Wait, did you say videos like SLEs aren't going to be worth points?
They're not worth points because I'm teaching you live.
Oh, yeah. So just the homework will be worth points?
Yeah, you'll have the homework and then tests and quizzes and who knows?
So it's basically just like
without
the SLEs. It's basically just like what we had without the SLEs.
Yeah. So that's kind of my plan. So that's what we're going to be doing with that. All right. So we are good to go. So let's let me stop sharing here, bring us back to this screen. We have everybody in. So if you have something to write with, great. On a sheet of paper, great. Obviously, I will eventually, once we get back, I will get you packets of notes that you can take when we are teaching live, whether it's on Monday or like this, or if it's on, in class, whether it's Tuesday, Thursday, or Wednesday, Friday, depending upon your cohort. I don't know if you heard, the Monday schedule is kind of goofy. There probably was an email home. I know y'all have gotten way more emails than you ever anticipated in your life. Me too. But Monday's schedule will be like 1, 2, 5, 6, and then it'll be 3, 4, 7, 8. And that's for the students that are going to the CCIC campus. That's the Career Innovation, Cherry Creek Innovation Campus, or whatever it's called. I think that's about the right name. So that's what we have. So are y'all ready to do some notes?
Yes, sir.
Yeah, baby. All right, let's have some fun. So we are done with this class today at 1:05. So over a half an hour left. Woohoo! All right, so I'm gonna go here, and let's have some fun. Okay, so solving systems of linear equations, and we're gonna solve by graphing, okay? There are 3 different methods to do this. Actually, there's multiple methods, but we'll learn about 3 of them in class. We'll do 1 of them today, and we're gonna do it by graphing. And the graphing method is the same method that we were learning about graphing originally with the with last semester. Okay. So first one, how do we solve a system? 3 methods. Well, we're going to deal with graphing today. We'll deal with 2 and 3 at a different time. So next week sometime. So graphing just basically means if I graph 2 lines on the same XY axis, which I did draw the XY axis, where they cross is called the solution. And the solution is a point. So you put both the X and the Y component as a point, and it'll get it in there for you. Seem good so far? Let's see. Should be all right. All right, so after that, we're going to take a look at this problem. So we're going to graph these 2 equations. So the first one we'll go ahead and do in red, the same as what's up there. So this one is set up to find the y-intercept. The y-intercept is going to be 0, 1. Remember the letter B, when we have it as y equals mx plus b, is the y-intercept. So 0, 1. So you come over here, you plot the point 0, 1, and you're off and running. From there, you're going to find the slope. So remember the slope is attached to the x. So my slope in this equation is going to be 3. And I'm going to write it as 3/1. That way we can use the slope. Remember, the slope is a map to find you a second point. So from this point that we already plotted, I'm going to go up 3 and write 1. And then I'm going to use myself a straight edge because I have those. And I'm going to draw in my line of best fit best way I can. So that's our first line. Okay, we don't have any solutions yet because we don't see 2 lines graphing on there, but we do have the line drawn. Okay, so let's do the second line. We're going to do it like this, and this one looks like the cover method. Remember, the cover method finds us the x and the y intercepts. So I'm going to write 0, blank and blank, 0. And then I always like to have kind of a shape that we put up there, and maybe we'll fill that with a fun color of purple or something. And so I'm going to take a look at this first. So that first 0 that my block is underneath, is an x value. So I'm going to put that over top of that. So I get y equals 6. So I wind up with 0, 6. So 0, 6 is up here. 3, 4, 5, 6. It's up there. Then I'm going to take that away and say, okay, now I need to figure out this. Well, that's a y value where that is at. Okay, so I'm going to cover my y value. So I get 2 times what number gives me 6? 2 times what number gives me 6?
3.
3, thank you. So that becomes a 3. So then I could plot 3 comma 0, which is right there. It finds me both my x and my y intercepts by doing that. I'm going to use a straight line again. I'll make this one blue because my dots are blue. And I did a bad job. Let's try that one more time. There we go. So it does indeed appear that my 2 lines are crossing each other, which is great. That's what I want. Where they cross each other is the solution. So we're looking for that point right there. So it's 1 comma 1, 2, 3, 4. 1 comma 4. That is our solution. Okay. So 1 comma 4 is the solution where our 2 lines cross each other. Okay. So with that known, let's talk about where this math has taken place in your life. Well, all of you logging on to this today had to use this type of math in order to get you in, because you had to log into My Cherry Creek. You had to put in a password. So your My Cherry Creek creates one linear equation. Your password creates another linear equation. Where they cross is the solution. And they know that when you plug that in, that solution works, and that lets you into the program. This also works with your fingerprint on your phone, or your face recognition on your phone, or typing in your access code on your phone. Okay, so it works pretty nicely with that. So we have a solution here. 1 comma 4 exists on our red line. 1 comma 4 also exists on our blue line. It exists on both of those lines at the exact intersection of the 2. So that creates our solution to the problem. May I move to the next slide, please?
Yes.
Yay. All right, so we're going to go ahead and try graphing these. These are the same equations that are below, so I'll go ahead and do this one green. So it looks like I have a y-intercept, which is our b value of 0 comma 5. So 0 comma 5 is right up here. And then my slope, well, there's a 1 in front of it. So my slope on this one's going to become 1 over 1. So from this point, I'm going to go up 1, right 1. Now I have 2 points. 2 points will define us a line. Huh. 2 points do a straight line. And I have a student who's supposed to be here for next period. Hey, Dan.
Yeah.
12:40, or excuse me, 1:10 is when we'll have class.
Oh my God. Okay.
Thanks, bud. All right, so those 2 points, I'm going to go ahead and create my line of best fit. My line of best fit, we'll do them green. And I'm going to just draw it just like that. So we have a nice straight line that incorporates those 2 points. We'll do my second equation. Maybe we'll do it in blue. So remember, this one's missing that y value, that b value being 0. So I have a y-intercept on the second one. It's missing, but my y-intercept on this one would be 0 comma 0. Okay, and then I have a slope of -4. So that means -4 over 1 is my slope. Okay, -4 over 1 is my slope. So from here, I'm going to go down 4, right 1. Okay, and I could have went up 4, left 1, but you don't necessarily need 3 points. I just did it because I made it easier for me. Go ahead and graph this. I'll graph it as a blue line. And lo and behold, we get a green line and a blue line. They happen to cross each other, so there definitely is a solution. This is our solution right here. And this solution happens to happen at -1, and then 1, 2, 3, 4. -1 comma 4. So my solution here is -1 comma 4. Now, graphing is a great visual way of graphing linear equations to find the solution. But here's the problem with graphing. Not all lines have to cross at a nice, two nice numbers. They could cross at decimal amounts. Okay, you could have a line cross at 0.2577, comma 3.6625. That's really hard to graph to find that exact thing because it's pretty far away. Okay, so the ones that we're working on right now, they're nice because they have nice whole number solutions. The other methods that we'll learn later next week will show us how to determine, when we don't have nice values. Okay, so -1, 4 is indeed the solution. And again, I told you that this type of math, excuse me, works with the computer algorithms on your telephones or your computers, and that's with your passwords and stuff. Okay, it also works like if any of your families have like a car that you don't have to put the key in to start it, you just have to basically have the key in somewhere around the car and you hit the start button. Same idea. It's the same exact thought process that's taking place. That's why things like computers and phones and cars and anything that has a password, that's why it is a hackable thing, because you're just figuring out the computer or the math algorithm that they're using for their system for the password, and that's why you can hack into it. Okay, so until they change that type of algorithm, you'll deal with hacking. And I'm sure if they get some better version, I think everything eventually is hackable at some point. If you are somebody who likes to try and get into other people's stuff, which it is what it is. Hacking computers is it's just a way of life. Okay, so what are we looking for? We are looking for where our lines cross, and we're going to call that the point, and that would be the solution. That'd be the solution. So that solution means that point, that's the solution, exists both on the x and or both on both lines. Okay, am I going too fast for anybody? Does everyone feel comfortable with what I talked about so far? Good to go? Okay, I'm not going to do this little thing. It's a goofy video and I don't prefer it. Okay, but then there's another way. Now, we're not asking you to graph it. We're asking you to verify, saying, hey, is this the solution to these? Is it the solution? Well, you have to understand, well, this is an X and this is a Y value. So if I plug those values in to my X and Y values on each, so if I plug into this one, my Y value I know is -3 times negative or equals -2. My X value is 4, and then I get +5. So I get -3 equals -8 plus 5. So I wind up finding getting -3 is equal to -3. Well, that totally checks out. -3 is indeed equal to -3. So that means 4 comma -3. If I had graphed the line y equals -2x plus 5, 4 comma -3 would exist on that line. Okay, then I'm going to take the exact same values. Again, these are X and Y values. I'm going to plug it into this equation to see if it works. Well, they tell me my X value is 4 plus 2 times my Y value is -3. And is that equal to -2? Well, I don't know. Let's do the arithmetic. So 4 times -6, because 2 times -3 is -6. Is that equal to -2? So 4 subtract 6 is -2. Is -2 equal to -2? It sure is. Okay, so being that these are both true statements, 4 -3 is the solution. If these lines had been graphed, this point right here would be the point 4 comma -3. Okay, it exists on both lines. It's the point that is shared between the two lines. Okay, so that's one way. You have to plug it into both. Now, it's possible that the point they give you works only on one and not the other. That means it's not a solution to the system. A system means we're graphing more than one line. It doesn't have to work on both. If it doesn't work on both, that would mean it's not a solution either. So then we're going to go down to this next problem and say, okay, well, this is an X and Y value. I'm going to plug that X and Y value into here. So I'm going to get 3 times my X value, which is 1, minus y, which is 5 is my y value. Is that equal to -2? So I get 3 minus 5, that's equal to -2. That means -2 equals -2. So that is correct. So that means 1 comma 5 exists on that first line. So then if I do the same thing with this one, if I say, okay, well, that's an x and y value, and I'm going to plug it in here. So I'm going to get 5 is equal to 2 times 1 minus 3. So I get 5 equals 2 minus 3. So 5 equals -1. Well, is 5 equal -1? Not this week. So is this point a solution? Not a solution. Not a solution to these problems. It's not a solution to it. Okay. What this graph would look like if we had graphed this one would be, it would look something like this. You'd say, here's my point. Say this is the point 1 comma 5. So it works on this line, but it doesn't work on the other. So that's kind of what it looks like. And then obviously if the point doesn't work on either, the point would not rest on either of the lines. So plug in the point that's given to you to see if it gives you a true statement. If it gives you a true statement on both, it's a solution. If it gives you a true statement on one, but not the other, it is not a solution to the system of equations. It means that you plugged in the wrong password on your phone, or you used your wrong fingerprint to get into your phone, or you aimed your phone at your friend's face and it doesn't recognize that face, so it doesn't work. Basically, facial recognition works basically is the ratio between your eyes to the distance to your nose to the distance to your mouth. We all have a different distance. Okay, no two people are the same. There are some people that are very close. Obviously, identical twins are very close. It might actually, it depends how well the parameters are set up on the phone. It's possible that if you had a twin, same gender sibling as you, it's very possible if you have the facial recognition on your phone that it might register both you and your sibling. But again, it has to do with how fine-tuned the parameters are. Like if they just measure to the nearest inch, you have a margin of error. If they measure to the nearest nanometer, so 10 to the -8 meters, so we're talking about, 1,000th of a time of a millimeter, you're talking about a really small little thing like the size of a thinness of a hair, it's going to get a lot more exact. Okay, obviously the more exact systems work, it costs more money to make it a lot more exact. Okay, so how many solutions can a system have? So this first one, they went ahead and graphed it for us. Oops, let me move that up a little bit. So we went ahead and graphed the first one, and we do indeed, we have this point, we have that XY point, it works on both, so this has one solution. Okay, there is only one point that you can plug in that will work for both equations. And then you can look at it and say, okay, well, what about if we have two lines that are parallel to each other? Well, if they're parallel to each other, they won't cross. So if they're parallel to each other, you have zero solutions. There is not an XY value you can plug in that will work on both equations. And then there's kind of the silly one, but it looks like this. And it's like, well, I only see one line. Well, that means that if you had graphed this first one and you had graphed the second one, being there, one's in slope intercept, one's in point slope, they actually are the exact same equation between the two lines. Okay, the exact same equation between the two lines. So if they're the exact same equation between the two lines, this means we have infinite solutions. Okay, there is an infinite amount of ordered pairs that I could plug in to both equations that would work. Now, I'm not talking about the point over here. That's not a solution. I'm talking about if I pick anything, any ordered pair along this line, and I plug it into both of the solutions, it will work. So you can either have one solution where the two lines cross. You can have no solution if your two lines happen to be parallel to each other. Or you could have infinite solutions because you graph the exact same line right on top of it. So you have one solution, parallel lines, trying to make that work so they don't cross, or you could have one line on top of the other. Okay? Questions so far, my friends?
Mr. Stirrup,
Yes, sir.
we're still gonna have videos in Schoology about all this, right?
Yeah, I'm actually recording this right now. So this video right now with your question that you just asked are on the video that I will post later today.
Okay, thank you.
Cool?
Yeah, sounds good.
Yeah, buddy. It's just the videos aren't going to be worth points now because I'm teaching you live. I'm not having a video for you to watch. Does that make sense?
Okay.
Okay, can I move on to the next screen, my friends? I'll take silence as yes. Okay, so we are done with what we did, but what I want to do is I want to kind of back up and I want us to recall our graphing that we had done. Okay, so there was slope-intercept. Which would be like y equals mx plus b. And we know that the y-intercept on this one would be the point 0, comma b, and then the slope finds another point. So if I just had a rough graph of something like this, if I said I want to graph y equals 2x minus 3, I'd plot -3 down here, and then I would go up to right 1, and we'd have that. So that's our first method of graphing. That's slope-intercept. So when it's solved for y. Okay? So that's our first one. Can I move on? So this is like all last semester.
Yeah.
The next one is, we called it the cover method. And the cover method is when it is in something called standard form. And standard form looks like this: ax plus by is equal to c. And what this finds us is it finds our x and y intercept for our 2 points. Okay, you don't necessarily have the slope known on this, but if you had this type of problem, if you had, say, 2x minus 3y is equal to 12, this is the one where you go 0, comma blank, and blank, comma 0. And then you realize, okay, that's an x value, so you cover up our x value. So you go -3 times what number gives me -12, or 12, and this would be -4, so 0, -4 is down here. And then this is our y value, so I'm going to cover up this portion now. So 2 times what number gives me 12? Well, that would be 6. So that gives me 6, comma 0. 1, 2, 3, 4, 5, 6. So those 2 points exist. So that's 6, 0. And that is 0, -4. And so that works. So the cover method is kind of a fan favorite because it definitely works nicely for us. Okay. And then the one that we don't see very often, we call it point slope. And point slope looks like this, where our point that we establish is x1, comma y1, and realize those are opposite from the equation. And then we have our slope that finds our second point. So how this would work is, let's say we had something like this. This would say, well, we have the point -4, comma 2, which is here. We have a slope of 3, or 3/1. So from here, I'm going to go up 3, right 1, connect the dots. Okay, so you have point slope, which the point is given to you, then you use the slope to find a second point. You have standard form, which is where we use to find the cover method. That's when the x and y are on the same side, and you cover up the things, make sure you do the 0, comma blank and the blank, comma 0. and then we have the slope intercept, which is when we have it solved for y, and you plot your y-intercept first, so 0, b, and then you use your slope to find a second point. Okay, and then there's two special cases that we have to remember. So you can get x equals a number, and this is a vertical line through the number, and we have a slope, which is m, which is undefined. Okay, so that's the first thing. The other special case would be if we have y equals a number. We don't have anything else. We don't have any other letters. This is a horizontal line through the point. Or through the number, excuse me. So this would have a slope m, which is equal to 0. Okay, so those are the special cases that you might come across. All right, what kind of questions do you have for me? Are we doing okay?
Yeah.
I have a quick question.
Yes.
So my question is, say that you were to have a cover method on during this whole thing, like for solving the system, what would happen if it's not possible to go into the number? Does that just mean that the line does not exist?
Okay, so like let's say you're doing the cover method and you had like 3x equals 10. So then you'd get 10 over 3. So then you have to figure out where 10 out of 3 would be on the number line. So that's why the cover method isn't always great, because sometimes the cover method doesn't always yield you an exact value you can see on an XY axis grid when you're counting by whole numbers. Okay. So that's what takes place there. Let's see. Okay, so friends, I will have this video posted on Schoology. Do you need to go watch it again? No.
No.
If you missed class, if you ever miss class for whatever reason, I will always have that video there for you to watch. And you don't know you get points for watching it if you miss class. Just make sure you do take care of your own stuff. Watch it. That's a nice little gift. You have the ability to watch the video, and that should be pretty cool. But I will post that on YouTube. So in case you miss, or if you have to go back and say, you know what, I don't remember how to do this. Well, maybe you just go and watch the video. And the nice thing is, because I had the videos now going to be posted on YouTube link, you can fast forward to where you need to get the information you needed. You're not bound by, oh my gosh, it's an 8-minute video. I have to watch the whole thing. It's like, I think it was like halfway through. So you go to halfway through. Yeah, that's what I need to know. So you can scroll back and forth on your toolbar to get that information. Now, I will have homework for us that will be due on Monday. So when you log on to our page, notice I have HWSSLE number 1. That's solving systems of linear equations, number 1. This is in the workbook. No, you don't have the workbook yet because you haven't bought it, but you can either print off that PDF file, or you can just copy it on a separate sheet of paper to make it work for you. And then on Monday, you'll have to show me on video what you had work for you. Okay.
Is this part of a new book or is this part of the same book?
Actually, that's a great question. You know what? If you do have your book, this is actually in your book. So find
it's on the same pages. I checked. It's on 111 and 112.
Oh, 111, 112. Thank you for checking that. Yeah. So if you have the book from last semester, we didn't quite get done with last semester, so we started with this. So yeah, so if you have the old book, these pages are in there. So it's your choice if you want to use the old book or if you want to print this page off, or if you just wanted to copy this page on a separate page. So just show me once it's done. Okay.
So how do we purchase the new book?
What you'll do is, how do I get a book for the class? You click this, you go to this, this link, it'll take you in there. You tell them what book you're looking for, CP Algebra 1, second semester, and buy the book. And then you'll have to swing by the bookstore, Bare Necessities in the IC building when you're on campus, and they'll have it for you.
Awesome.
As each name gets called, the anxiety only grows for those unclaimed. If a team passes, can I call them and be
I muted Liam because he's obviously doing something else. All right, so can I stop recording? Anybody have any other questions? All right.
Nope, I'm good.